How are you doing? Thank you so much for joining me with another math lesson with Mr. Whitford. Today we continue to work on our Unit 7 unit talking about expressions and equations and solving equations. And we're going to look at 7.9. We're going to be talking about two-step equations, specifically fractions and decimals included. So as usual, take a moment right now, pause the video if you need to begin to complete the bell work. Awesome. Now, I am going to go through the bell work with you, hoping that, if you need to pause the video at any moment throughout the video, feel free to do so. But I want to go through it and try to recap once again what we're doing here. We're solving equations, and the way we solve equations is we need to get the variable by itself. Now, what is a variable? A variable is a letter. It can be X, Y, M, Z, theta. Anything that's not a number can be considered a variable, an unknown. Right, in this case here for A and B, you're solving for X. Those are the variables that you're given, and you have to solve for it. And at first glance, it looks like they're the exact same thing. You see X divided by 2 plus 4 equals 5, and then you see a 4, a 2, and a 5 in B as well. But ladies and gentlemen, let me tell you right now, the answers are completely different. They are completely different in the sense that you need to do the inverse operation. Now, what is inverse operation? The word inverse means opposite, and operation means opposite operations. So if it was addition, you would do subtraction. If it was subtraction, you would do addition. If it was multiplication, you do division. And I'm pretty sure you got it by now. But how do I do that? And in which order do I do that, Mr. Whitford? Good question. Now, the order in which you need to use in order to solve two-step equations is really in the reverse order of how they affect the variable. Let me try to explain that. For A, when I look at A, I can see that right away, I see X divided by 2 plus 4. So what's happening to X first? X is first being divided, and then it's being added in order to get you the answer. So first there's division, and then there's addition, right? First there's division, and then there's addition, right? And if I want, let me actually just write this down for you guys so you can see it, all right? So when I see what's going on here, I say first thing that's happening here, it's just being divided. And then the second thing that's happening is being added. Now, if I need to solve it, I need to go in the reverse order in order to solve it. So I need to go from the bottom up, doing the opposite operations. So my first step here will actually be to get rid of addition by doing subtraction. That's my first step. Then my second step is going to be to get rid of division by doing the opposite, which is multiplication. Okay? Let me say that once again. I first identify what's happening to X. What is happening next? X is first being divided by 2. Then it's being added by 4. Okay? So I need to do the reverse of this. I see division, addition. I'm going to do the reverse, saying first is get rid of addition by subtracting. Then we're going to get rid of division by multiplying. And notice that I could have, if I wanted to, and I should, put the actual numbers. This is being divided by 2. That means it needs to be multiplied by 2. This is being adding 4. That means this needs to subtract 4, right? Just to give me further detail. So first thing I'm going to do is subtract 4 to both sides. Then I'm going to multiply by 2. That is how I'm going to solve this. So actually, I'm going to draw my line first. Then I'm going to subtract 4 to both sides. I'm going to notice that these 4's cancel out. I get X over 2 is equal to 1 because 5 minus 4 is 1. Then I'm going to multiply both sides by 2. That cancels out the 2's. I get X is equal to 2. Now, even though this is my answer, ladies and gentlemen, you should get into the habit of checking your answer, right? So I'm just going to quickly check the answer, make sure it makes sense here. I'm going to put a little CK here, which stands for check. And I'm going to plug in 2. So 2 for X divided by 2 plus 4, does this equal 5? We know 2 divided by 2 is really 1. So 1 plus 4, is that 5? And the answer is yes, 5 is indeed equal to 5. So this does make sense. Notice how we first figured out the order in which they're affecting X. Then we went in reverse and did the inverse of each one of those operations. So let's do the same thing over here. What is happening to X first? What is happening to X first, right? If I look here, I say, okay, X plus 4 divided by 2. Notice how I'm reading it. I'm reading it intentionally to figure out what operations are happening. I wouldn't say X divided by 2, then plus 4, because it kind of shows that X has to add to 4 first. So it shows me that first thing that's happening is being added to 4. So they're adding 4 to both sides, okay? Then I say, okay, x plus 4 divided by 2. Then it's saying divided by 2. Okay. Now, because we want to solve it, we need to do inverse operations and we need to do it in the opposite order in which we set it. So instead of taking care of addition first and doing subtraction first, we're going to take care of division first by multiplying by 2. And that's a MUL there. I know it's kind of quickly made a circle, but it's multiplying by 2. And then I need to do the opposite of addition, which is subtracting by 4. And if I did this order here, it should give me the answer. Let's check it out. First thing I'm going to do is draw my line down the equal sign. I need to, first thing I'm going to do on this side is multiply by 2 to both sides. Multiply this side with 2, multiply that side with 2. That's going to cancel out the denominator. I end up getting x plus 4 is equal to 10. Now I have to subtract 4 to both sides. Because once again, our goal is always to get x by itself. And we get x equals 6. Notice the answers are different. One is 2, one is 6. But I want to make sure I check the work to make sure it makes sense. So I'm going to check the work by plugging in 6 for x. So 6 plus 4 dividing by 2 is this equal to 5. 6 plus 4, we know that's 10. Is 10 divided by 2 5? The answer is yes, 5 is equal to 5. So in this case, the answer is 6. Okay. Now, what I just did for you in the bell work B specifically is actually the very first modeling problem. But I want you to make sure you pay attention to the order in which it's affecting the x. That's the first key. After you draw your line down the equal sign, say, okay, well, what order is it happening to x? Is it adding first to x or is it dividing first to x? What's happening to x first? And then you can begin to say, okay, well, that one I need to save for last. And if you need to write it out exactly as I did here, that may help you see it step by step in order to figure out exactly how to do this, okay? Of course, as usual, there are steps here for you. I wrote the steps out, draw the wall, get rid of the number being added or subtracted first, right? Now, these rules only apply to ones that look specifically like A. However, when they look like B, you got to make sure you understand which one is happening to x first. And in that case, x plus 4 really happens first. Because when you see this type of fraction, it's kind of as if there's parentheses at the top to say, okay, take care of this stuff in the parentheses first. And I know there aren't really parentheses there, but you can kind of indicate that there might be because that's how PEMDAS works. Parentheses will go first. Okay, so A, once again, is exactly what we just did in bell work B. So I'm not going to go through A again with you, right? If you want, take a second to see if you can do A and then compare it with what I did above. And try not to look at what you did on your paper above and see if you get the exact same thing I did. That way it kind of tests yourself. But I will go through modeling B. I will go through modeling B. Now, what's the difference between modeling B and modeling A? One, I noticed that there's not an X, there's an M. So I want to solve for the variable M. I also notice here, obviously you notice probably as well that there are decimals. And the decimals for 7th graders could be paralyzing. So try not to get paralyzed at this moment. Try to take a deep breath and say, okay, you know what? I can do this. I can take care of this, all right? And the way we're going to take care of this is we're going to first draw a line down the equal sign. That's our first thing we're going to do. Draw a line straight down the equal sign, right? Whenever we go to solve any equation, we say line straight down the equal sign. The next thing that we do is we then decide, okay, I want to get M by itself. What is happening to M first, right? So this is a time for us to write out what's happening to M first. First thing that's happening to M is I see is being divided by 2.8. What's the next thing that's happening to M? Then I see is being subtracted by 4.9. So these are my steps. So since I want to go in the reverse order here, I want to go in the reverse order in order to solve this. I want to take care of subtraction first. So really my first step is going to be to do the opposite of subtraction. I'm going to add. I'm going to add 4.9 both sides. My second step is going to get rid of that division by multiplying by 2.8. And now that I have it set up here, this should be able to help me solve it. Now, you have a calculator, be very careful because I see a negative 7.11, I see decimals, and I know if you try to do it, you could do it on a calculator, there's no doubt about it, But be very careful when you put it in the calculator, type in the right buttons, the right numbers, especially if you're using the TI-30XII. Once again, there's a difference between the subtraction button and the negative button at the bottom. Okay, let's do it. So first things I'm going to do first is I'm going to add 4.9 to both sides. Okay, when I add 4.9 to both sides, I see the left side cancels out. It leaves me with just m over 2.8 is equal to negative 7.11 plus 4.9, which is going to give you a negative 2.21. All right, that's the first step. Okay, double check your math. If you got anything other than that, you want to double check to make sure it's 100% correct. Okay, the next thing I'm going to do according to my steps is I need to multiply. I'm going to multiply this side and I'm going to multiply this side. Now, what am I multiplying by? 2.8. Okay, multiply both sides by 2.8. 2.8 cancels out. I'm left with m is equal to whatever this gives me when I multiply the two of them. And that's going to give me negative 5.0388. Now you're like, Ms. Wilbur, can I just round that answer? You could, but I would not. Right? If you rounded it, your answer would not be correct anymore, because then when you go to plug it in and check it, it won't give you the right answer. Putting this answer in is the right way. The decimal stops, so it's okay, right? And hopefully all your answers have rational numbers, which means that they have terminating decimals, and that will help you to be able to check your answer. Now, I am going to go back and check my answer because I do want you to get into a habit. Every problem on this worksheet, go back and check your answer. Even when it gives me a weird decimal like this, Mr. Woodford, yes, okay? We'll put this all over 2.8. I'm going to subtract 4.9. And I want to see if that's going to equal negative 7.11. Okay, this is my check. First thing I'm going to do is I'm going to divide that. All right, I'm going to take this answer, I'm going to divide it by 2.8. Right? Let me just do it one more time. 5.0388 divided by 2.8. Okay. When you do that, you get this negative 1.79957 143. And I'm hoping that my calculator isn't chipping here. Okay. Now I'm going to subtract 4.9 from that. Okay. Now on your calculator, because I'm actually using my phone, and my phone may be rounding some of the numbers and give me the answers that are off. I say that because as I'm going to check, I'm noticing, no, it's not working right. It's not working right, which is okay. This is me understanding the math and saying, this doesn't make any sense. Okay. Yep. Okay. So I'm going to go back and just double check my answer from above because I want to make sure that's 100% correct. You know what? And it's wrong. Just like that. Maybe there was something I put in my calculator that was incorrect, but that's not my answer. And I noticed that because when I go to check it, the check is not making any sense. Check is not making any sense whatsoever. So, and look, see exactly what I'm doing. This is a good time for you guys to all see. It's okay to get the wrong answer because when you go to check it, it's going to determine if your answer is indeed right. Mine isn't. The correct answer, and I'm going to double check all the math because I want to make sure it all makes sense here. Yep, it should be -6. And some of you guys probably got that and said, Mr. Wilfred, that don't look right. -6.188. Okay, -6.188. Now I'm gonna go back and just once again, I'm gonna put it in for the check. I want to see if this makes sense. I'll take that answer, I'm gonna divide it by 2.8. Good, now it's making more sense, right? And I'm going to subtract the 4.9. And yes, I do get the -7.11. Now, this is the right answer. It gives me -7.11 is equal to -7.11. Okay. And there's nothing wrong with getting the wrong answer, but then going back and check it. Notice that all the work was right, but my computation was wrong. I put in the calculator a little bit wrong, so it gave me the wrong answer. Be very careful as you go through it, okay? Anyone can make mistakes. We're just plugging in numbers into the calculator. But if your technique is right, when you go back to check it, you should say, something went wrong. Let me just check it, just like I did. All right. Thank you guys so much for joining me. If there's any questions at all, feel free to put them in the Google Classroom. Continue to work on the independent practice as well as the homework worksheets to gain a better understanding of the content and gain mastery. Thank you so much. Have a wonderful day.